We found that if p and q are prime, phi of p is p minus 1, phi of p to the k is p to the k minus 1 times p minus 1, and phi of pq is p minus 1 times q minus 1. But what if we have a product of 3 or more primes? So to move forward, it helps to remember that organization matters, and concrete never hurts. Let's take a look at phi of pq again. When we found phi of 15, we noted there were 5 numbers that had a factor of 3, and 3 numbers that had a factor of 5. If we arranged our 15 3 times 5 numbers into a 3 by 5 grid, we note a useful pattern. All the multiples of 5 are in the same column. And if we rearrange the numbers in the columns, we can put all multiples of 3 in the same row. This leaves 4 columns of 2 entries, which is how we got our phi of 15. So that's what happened if p and q were prime. What if p and q are relatively prime? So let's try to find phi of 12 this way. So 12 is 4 times 3, so we can put down 4 rows of 3 entries. We can eliminate all entries in the third column because those are not relatively prime to 12. And in the remaining column, exactly 2 of each column can be eliminated. And so again, we can rearrange this to give us 2 columns with 2 entries. And note that we also have phi of 3 is 2, and phi of 4 is 2. And this suggests a general approach. Let's find the number of numbers relatively prime to 36, that's 2 squared times 3 squared. So this is the product of relatively prime numbers, and since the greatest common divisor, 3 squared and 2 squared is 1, we'll set up a grid of 3 squared 9 columns and 2 squared 4 rows. The numbers not relatively prime to 3 squared 9 are 3, 6, and 9, and note that every number in these columns is also not relatively prime to 9, so it won't be relatively prime to 36. So we'll eliminate those columns, and that leaves us with phi of 3 squared 6 columns. Now consider any of the remaining columns, say the column 7, 16, 25, 34. And of these, only 2 are relatively prime to 4. That would be these 2. So in each column, there will be 2 numbers remaining. Now, without actually looking at the columns, we won't know which numbers are remaining, but we do know that only 2 will be left over. And because this is a concrete example, let's go ahead and find those. Now, this means the remaining numbers will be in phi of 9, 6 columns, and each of these columns will have phi of 4, 2 entries, for a total of 6 times 2, 12 numbers that are relatively prime to 36. And so phi of 36 is going to be 12. This suggests that in general, we'll have phi of p columns with phi of q entries, so we'll have phi of p, phi of q entries remaining. So if the greatest common divisor of p and q is 1, then phi of pq is the product of phi of p and phi of q. Or is it? Well, let's see if we can find a proof.